are gonna talk about time and space complexity, a fundamental concept that you need to master when working with algorithms. It is something that you will come across over and over again, especially in coding interviews and while optimizing your programs. So if you have ever heard terms like a big O of n or wondered how to measure the efficiency of your code, now in this video you will learn about it. What is a time complexity? Time complexity is a way to express how the running time of an algorithm grows as the size of the input increases. In other words, it helps us understand how fast or slow an algorithm will be when it is dealing with small inputs versus huge ones. Imagine you are writing a program to find a number in a list. The way you search through the list will determine how much time your program will take. Time complexity gives us a mathematical way to express this behavior. Let's imagine that example list that you are working on is very small, maybe 10 elements in a list. But what if there will be 1,000, 10,000, 1 million elements in a list? How running time of the algorithm will differ when the input size grows. So that is when we introduce big O notation. Big O notation is a standardized way to express the performance of an algorithm. When we say an algorithm has a time complexity of On, it means that the time it takes to run increases linearly as the size of the input increases. Let's start looking at example big O notations. When we discuss in algorithms in the coming videos, we will mention lots of different big O notations. But we can start with O1. This is called constant time. So that means that it does not matter how big or how small is your input. It will always take the same amount of the time. An example can be is like accessing an element in an array by index. If you have 10 million elements in an array, accessing by index will always take constant time. Now we can move to On. This is called linear time. This means that the time taken increases in direct proportion to the input size. For example, if you are iterating through a list of size n, checking each element once, you will have a time complexity of On. Let's look into it. Let's say that we have a list and we have maybe 6, 7, 8, 9, and 10 elements. So accessing each element in a list, we need to do some calculations, like at least like a check the element in each index. But let's say we will do 10 operations, right? In this size of list. But what if this input size increases 10 times? So that means it will be 100 elements. So when it's 100 elements, we will do 100 operations. We will access each element once, and we will just like read the element of the element maybe. So that means that from 10 elements, we increased it to 100 elements. So that means that input size increased 10 times, and the time it will take will increase 10 times. So if we increase the input elements 10 times, the time taken to run that algorithm will also increase n time in big O notation. So that's what it means. Now we move to quadratic time, and that is notated by On square. This happens when you have nested loops. If you have an algorithm where you need to compare each element with every other element, we can take bubble sort as an example. The time complexity is On square. If your input size doubles, the time taken increases 4 times. So that means that if we take like a previous example, kind of like a scenario, if we increase the input size by 10 times from 10 to 100, that means that the time taken will increase n squared times. So that means it will increase 100 times. That's why it's called quadratic time. And we also have O log n. That's called logarithmic time. Algorithms with logarithmic time complexity are super efficient. A common example is binary search. We will also look at this in the coming videos. So for now, that's enough about the time complexity. Let's move to the space complexity. But as I mentioned, you will learn about this stuff moving forward in the coming videos.